Hello everybody and welcome to exercise 2 on page 30 of the workbook. And this problem is about finding rates of change in kind of a qualitative setting. Let's read this question together. So let P equal F of A, R, and N, where P represents the monthly payment for a mortgage, A represents the initial amount borrowed in dollars, R represents the annual interest rate in percent, and N represents the number of years before our loan is paid off. Okay, so we have a function here that has 3 input variables and 1 output variable. Okay, and they'd like us to start off by giving an interpretation of the statement f of 92,000, 14, and 30 equals 1098. Okay, and let's maybe start out before we try to write this interpretation and just match up the numbers to the variables that we have here. So we can see in our function that the input variables are A, R, and N. Okay, which means that those 3 input values are going to have to match those variables, and the output is P, our monthly payment, so that's the P. Okay, so our explanation is just going to consist of just kind of explaining what each of those 4 numbers represent. So we're starting out with a borrowing amount of 92,000. So if you borrow $92,000, next we come to an interest rate of 14%. Okay, then we come to the amount of time in the loan, and actually that's a capital N. Over 30 years. Okay, and then what's going on the right-hand side of the equation, that's just our monthly payment. So if all of that is true, $92,000 at an interest rate of 14% over 30 years, our monthly payment on the loan will be $1,090.80. Okay, so this is just a statement that's telling us how much we're going to pay monthly based on a certain borrowing amount, interest rate, and time of our loan. Okay, and that's our explanation for part A. Now, what about part B? So here they'd like us to give a practical interpretation of the statement FR of 92,000, 14, and 30 equals 7282. Okay, how is this statement different? Well, the 3 input variables are the same. Okay, so we're still talking about the same borrowing amount, interest rate, and number of years in the loan. But this is a very different statement because of the R that's here. We're talking about a derivative. So this is representing a rate of change, and it's kind of up to us to figure out, based on the notation, what it's a rate of change of. Okay, so I'd like to start this discussion with units. Okay, what are we really measuring when we look at this derivative? Okay, so I'm going to rewrite this. Okay. Well, our function, the outputs of our function are P, so we're talking about the rate at which our monthly payment is changing, and then the R down here is telling us what we're trying to measure the rate of change with respect to. So this is approximately the rate of change of our payment over our interest rate. Okay, if you look at the units there, our monthly payment is in dollars, okay, and our interest rate is in percent. So the 7282 that you see here has units of dollars per percent. Okay, you can think of it as the rate at which our monthly payment is going to go up relative to increases in the interest rate. Okay, so with that nailing down of the units, I think we're ready to try for an explanation of this statement. Okay, and the thing to remember is that the only input variable that's changing is R. The other 2, A and N, are being held constant, and we'll try to write that into our explanation. So if your loan is $92,000 at a fixed, let's say it this way, over a fixed time, of 30 years. Those are the two things that we know are not changing. Okay, and we start from an interest rate of 14%. Okay, and now finally we come to the actual derivative part of this. Then we're getting a rate of change of $72.82, an increase in our monthly payment by that amount for every percentage that we increase our interest rate. Let's see if we can write that down. Your monthly payment will increase by about $72.82 for every percent increase in the interest rate. Okay, so you can see that this explanation a little bit more complicated than the one for A. It's not as easy to describe a rate of change, but in a nutshell, this is telling us how fast our monthly payment is going to go up relative to the interest rate. Okay, and finally, let's take a look at C, which is at the top of the next page here. So they ask us, is partial P partial N positive or negative? So that's the rate of change of our monthly payment relative to N, the length of our loan. Okay, so let's think about this logically here. I'm going to draw just a rough sketch. We don't have a formula for this function, but we can kind of still think about it. So this is a rate of change of P, our monthly payment in dollars, relative to the length of our loan in years. Okay, and so to answer this question, I want you to think about the following situation. Okay, so if you borrow $92,000 for a house, in what situation is your monthly payment going to be the biggest? If your loan is 15 years long or 30 years long? Okay, where would your monthly payment be the biggest? Well, if you think about it, your monthly payment is actually going to be lower if the term of your loan is longer, if it's 30 years, okay, because you have longer to pay off that $92,000. So what that's telling us then is that our monthly payment should actually go down as the length of our loan time increases. We have longer to pay off the loan, and therefore our monthly payment is going to be less. All right, so let's see if we can put that into words here. Decreases as the length of the loan increases. That's really describing a negative slope. We can see that on the picture over here. And so that means that we should have a negative derivative. Partial P, partial N. Okay, which means that our answer is negative to this question.